Hello, everyone. In this lesson, we'll be doing graphing linear inequalities. Um, so, one of the things that you have to remember is how to solve for y, if necessary. You move the x term to the other side along with its coefficient, and then divide by the coefficient of y. Although for inequalities that's greater than, less than, make sure that you flip the greater than, less than sign if you divide both sides by negative. All right. Then we're going to plot points. You can use Desmos, or we're going to use the slope and the y-intercept. We need to know when to use a solid line versus a dashed line and when to shade above or below. So for solid lines, you want to use, if you're using greater than or equal to, or less than or equal to. That equal to is how you know to use a solid line. In contrast, the dashed line is if it's just greater than or less than without the equal to. Now, if regardless of whether it's equal to, if it's greater than or equal to, you shade above, and then less than equal to, you shade below. So take a look at this example. Y is greater than 2/3 x minus 4. Y is greater than 2/3 x minus 4. So we remember that if y is by itself, the term next to x is the slope. So the slope is 2/3. And then the y-intercept is the term that's not attached to x, in this case, -4. So you start with the y-intercept at -4, and you think to yourself, okay, slope is rise over run, so up 2/3. We can do it again for good measure, up 2/3. And you can even go backwards. You can go down to the left -3, because a negative divided by negative is a positive. It should all make a straight line. Now, looking up here, we notice that it is greater than, but not equal to. So we're going to draw a dashed line. It goes on forever, so that's why there's arrows. And then it's greater than, so you shade above. All right. And I'm not doing this perfectly, but you get the gist. We're shading above. Now, all this red shaded area is the solution region. Solutions can only lie in the solution region or on the solid line. Okay, keep that in mind. All right, so they give us some points. 3, -5. That's over 3. Walk to the elevator, then go down the elevator. 3, -5. Is that a solution? Well, you got to ask yourself, is it in the shaded solution region? It is not, so it's not a solution. All right, then what about -2, 3? Over -2, over -2 up 3. Well, that is definitely in the solution region, so yes, it's a solution. Finally, and this one's a little tricky, you have 0, -4, and that's right on the line. But since it's a dashed line and not a solid line, it is not a solution. It's only a solution if it lies on a solid line and it lies on a dashed line. Hence, 0, -4 is not a solution. Okay, next we have graph y is greater than -1/2 x minus 6. Do we have to solve for y? No, it's already solved for y. My m is -1/2. My b is -6. Is it a solid or dashed line? Well, there's no equal to, so it's dashed, and it's greater than, so it's above. So you go down, and you got to be careful how you count these blocks. Let's see, we got to go down to -6. So that puts us right here. And then the slope is -1/2, so down 1/2. And the more points, the merrier. Helps you to draw the best line that you can. Down 1, -2, down 1, -2, down 1, -2, but it's all going to be a straight line. You can also go backwards. You can go up 1 over -2, up 1 over -2, up 1 over -2, and drawing these extra dots, taking the time, it's going to pay off. All right, we said it's going to be a dashed line, not a solid one. Goes on forever. And then it's greater than, so we shade above. The solution region is above the line. And the dashed line, you can kind of think of it as this, the answer region comes right up to the line, but doesn't actually touch it. All right, so it's 5-2 a solution. I go over here to 5-2. It's kind of hard to see these numbers now. Yes, that is definitely a solution. I'm just going to write y for room. All right, -6, -3. It's right on the line. This is why it's so handy to draw those extra dots. Is it a solution? Well, it's a dashed line, so no, it's not a solution. And then -8, -8 is definitely out of the solution region, so the answer is no. Okay. Graph 8x minus 5y is less than or equal to 20. Well, do you have to solve for y? Unfortunately, yes. All right, so we cancel out the positive 8x, becomes negative 8x. Divide by -5. Now remember, if you divide by negative, you got to flip the sign. For room's sake, I'm going to write down here. So y is greater than. We flipped the sign. It was less than. Now it's greater than -4. A negative divided by a negative is a positive x. So my m is positive 8/5. My b is -4. Remember, the slope is what's next to the x if y is by itself. Don't get tricked by that. Now, there's a greater than part. There's an equal to part, so it's solid, and then greater than is above. So you come down here to -4. We got to make a huge jump up 8 over 5. And it's going to be a solid line. Let's see how well I can freehand this. All right, this wasn't perfect. I'm going to make since I'm making a thicker line, if you're doing this on paper, you can take advantage of a ruler. But you get the gist. It's a solid line, and we're going to graph. Let's see, we said above the line. So we're shading all this in, like so. It doesn't have to be perfect. You get the gist, okay? All right, so now let's start to fill in some points. 6, -5 is down here. No, that's not a solution. So we're going to write no. Oops. We're going to write no. And then -2, 5 is somewhere around here. Well, that's in the solution region, so we're going to write yes, y for yes. And then 0, -4 is right on the line, but it's a solid line, so we're good to go. Because it's a solid line, it's a solution. Then there's some other examples over here. I'll kind of go through fairly quickly. There's an invisible 1 over an invisible 1. So that's 1 over 1. And then b is +3. It's kind of hard to, let me try to zoom in here. The grid is so small. So you come over here to 3, and it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And, you could just keep going. Down 1, -1 over -1, down -1 over -1. But you get the gist, and it's a solid line. And y is less than. So you'll have to shade below. And for this, there was no asking if a certain point is a solution. It's just graphing. Okay? All right. The next one, they're making you work a little bit. You got to move the positive 3x, become negative 3x. Divide by negative, and remember that you have to flip the inequality. 10 divided by negative 5 is negative 2. A negative divided by negative is a positive. 3 over 5 will not reduce. All right, so you start at negative 2, and you got to go up 3. Now, don't be tricked. Just because it says 3 doesn't mean you jump to the 3. You have to start at the negative 2. Count up 3 over 5. All right, from the original point. Up 3 over 5. I think that this might trip some people up. You can also go backwards. Down 3 over negative 5. Down 3 over negative 5. And you know you do it wrong if it doesn't make a straight line. Now, it's not equal to, so you got to do the dash. And it's less than. So you shade down here where it says less than. Okay? All right, so then the next one, there's an invisible plus 0x. And this is a horizontal line. If the slope is 0, it's a horizontal line. And it's solid. And, of course, it's greater than. Let's see, this one, M is negative 2/5. B is negative 3. So you start at negative 3 and go down 2 over 5. Down 2 over 5. Or up 2 over negative 5. Didn't mean to make that line. Up 2 over negative 5. And it's a dashed line because it's not equal to. And then we shade above. And I think you get the gist. Remember, when you divide by a negative, you have to flip the sign. Also remember there's an invisible 1. All right.